Okay, so my name is Zach Ross, and in this video I'm going to be talking about my culminating activity for grade 12 computer science. And for that, I am making a autonomous vehicle simulation in Unity3D using C# as the programming language. So basically what it is it's autonomous vehicle simulation. So the vehicle is driven, it follows lanes, and makes all decisions through a program, not me, not a human isn't making any of the decisions. It's all the computer making the decisions. So I'm going to hopefully kind of go through what progress I've made so far. Doesn't seem like much, but it actually is a lot, and kind of explain the logic behind what's happening in the background, because it just looks like a car driving, but you got to remember that the computer's driving it, not a human, and humans are pretty smart, and it's really hard to make computers as smart as a human. So yeah, let's jump into it. So I think the first thing I'm going to talk about here is lane following. I think that was the first thing that I implemented because it's basically the most basic mechanic. It's still fairly complicated. It's the most basic mechanic, I think, for the computer and for humans is just following the lanes, staying within the lines, and not driving over the wrong lines. So I'm just going to show it here, and then I'll explain the logic behind it. So let's just click play. And as you can see, this car right here is basically just staying within the lanes. And you can see those two lines in front of it, which I'll explain what they're about in a minute. But it basically is just staying within the lanes and following them. And you can see as it approaches the curve, it's going to go around the curve. And then you can see it just continues driving, staying within the lanes. Okay? So now let's talk about the logic a little bit here. So as you can see right here, these lines, green lines right here, are basically little ray casts, and they raycast on either side of the car in front of it there, and they raycast outwards. And these raycasts basically are getting the distance between the line on your right and the line on your left. So it finds this distance here and then this distance here. Okay? And then it basically finds the average distance between them and the point which is in the center. So then the wheels will always try to steer towards that point. So in this case, it would be right in between the two lanes, the exact center point. And we want to always be steering towards that point in order to stay within the lanes. So this would be the center point right here. And the wheels on either side would make sure to stay completely lined up with that center point. And if the point were to, say, be over here for some reason, then the wheels would kind of steer a little bit towards that point to try and go towards that point. In this case, the point wouldn't be there, but if it was a curve and the lines were going like this, then the point would be there. So that's basically how the lane following works. So I think the second most simple thing is lane changing. So I'm just going to show basically how lane changing works in the simulation. It's just like normal lane changing. You don't want to lane change over yellow lines or solid lines, right? This solid line here, you were to lane change over it to the right, you would go off the road. And if you're in this lane and lane changing one over left, you wouldn't want to cross that solid yellow line because then you'd be lane changing into oncoming traffic. So there's basically those two simple checks. And so I'll just show you it working here. So I'm just going to give it manual input and tell it to lane change into the left lane. Okay, so right now, and there you go, you can see it veers into the left lane and then corrects itself and continues to lane follow normally. We're going to go around the curve here. And then once we're out of the curve, we're going to lane change back into the right lane here. There we go. As you can see, it veers into the right lane and then corrects itself. It's a little wobbly, but it works. So that's lane changing. Now I'm just going to go through the logic a little bit here. So this is right in the middle of a lane change. So when I tell it to lane change, or we'll get into it later, but it'll manually lane change if it knows it needs to be in that lane in order to make a maneuver at an intersection oncoming. But in order to make a lane change, it basically starts off by veering that direction, turns the wheels about 2 degrees, and then to know when to stop and recorrect itself with the new lane, the raycast for following the lane here, this green line right here, it has a distance to that middle center yellow line there, right? And when that distance gets to half the lane size, then it stops veering to the left and goes back into lane follow mode, which again will find the center point of the lane and correct itself for the wheels to follow that center point of the lane and drive straight once again. So that's basically how lane changing works. It's fairly simple. And of course, there's implemented checking your blind spot. So if there's a car beside you, it also will not lane change, because then it will run into the car, and we don't want that. Okay, so now I'm going to talk about basically safe following distance of the cars. So as you can see, we have multiple cars here on the screen. There's actually 4 cars lined up here. And basically safe following distance would be like a car's length. So basically it doesn't want to bumper to bumper each other. They want to follow at a safe following distance. Okay, so you can see a very basic example here of it. As these cars approach the intersection, the first one is stopping at this stop sign here, and all the other ones stop at the exact same time and keep their spacing nicely. And then when the first car goes again there, the cars proceed nice spacing, and they all stop at nice spacing. Okay, so that's basically basic following distances at a safe distance and stopping distances at a safe distance. So let's explain the logic behind it now. Okay, so again, I'm here in an above view here, and I'm going to just pause it mid-driving here in a minute. Basically what's going on is it is, first of all, not driving forward if it is less than, I think it's like 3 meters, so a car's width, let's say. So it will not drive forward if these distances here, right, are, let's get a different color here, you can better see that color. If these distances here are less than, say, 3 meters, it will not drive forward. It'll apply the brakes. Okay? But if they are greater than that distance, then it will find the velocity of the car in front of it, and if its velocity is larger than your velocity, it will speed itself up because it's safe to go forward, right? You won't run into it. Okay, so we can see right here these 2 cars now actually following each other kind of on a normal road. And you can see as they follow each other, they are keeping a safe distance and not running into each other. So I'll kind of just, right here. So right here, you can see this green line right here. And that green line is basically the raycast that is shooting forward, getting the distance and the change in distance, which then calculates the velocity. And then that depicts whether the car in front of you is going faster or not. And if it's going faster, you're okay to speed up. If it's going slower than you, then you would need to apply braking and slow down. So that's basically how the safe following works, so that they don't run into each other. So as you can see right here, I've basically just placed a wall in the middle of the road, which probably wouldn't happen, but just to showcase kind of automatic braking if there's an obstacle in the way. As you can see right here, this big green laser is basically sensing the distance to an object in front of the car, so it knows that that object's there, and if I click play here, it will stop in front of that object. It will not hit it. It as you can see right there, it recognizes it's there, and it's coming to a stop. It's not going to hit that object. And the reason why it's braking so far away is because that object has a velocity of 0, so it knows it needs to stop for it. As you can see right there, actually, this car actually also stopped because this car has a velocity of 0, so it knows, hey, I need to stop because there's something not moving in front of me. Okay, and if I were to click on this wall and drag it out of the way, the cars would proceed, and the cars would follow behind it because the velocity of the object in front of it is greater than 0 now. That's basically simple obstacle detection. So, now getting into some of the more complicated stuff, and that is intersections. So right here I have a 4-way stop intersection with 2-lane traffic, basically, and a whole bunch of Teslas lined up ready to approach that intersection. And, well, let's just click play here and see what happens. Okay? So, as you can see, there's a whole bunch of Teslas approaching the intersection, and cross your fingers, none of them will run into each other. Okay? So let's just watch it. Okay, so what you just saw there was fully autonomous cars making a decision whose turn it was to go at a four-way stop intersection. Okay? Now, this is one of the first things that you wrote the rules that you learn as a driver, and so I basically programmed it into these cars, and it's actually kind of complicated, so I'm going to try and explain exactly what's going on here now. Okay? This car right here is currently turning. It had the right of way, so it turned, okay? So this car is currently turning, so in logic, that would mean that this car here would be the next one to turn, because the one to its right just went. So that means that the next car to its right no longer has the right of way because the car to its left was there first. So that's basically how this is working, just like normal right of way. First person to the intersection gets to go. And if you approach the intersection at the exact same time as somebody, the person to your right has the right of way. Or if the person is in front of you, if they are turning left, you have the right of way. And if they're going straight, you both have the right of way because you're both going straight. Okay? So let's just click play here and just see this intersection continue to go. So yeah, like I said, that car had the right of way, it went. Okay, and then this car had the right of way, then this car, then this car, and then this car, and then this one, and it just keeps going around in a circle, right? Because that was the last one to reach the intersection has the first right away. This one, and it just continues going around. Okay? Now, how they sense the right of way. Basically, if you can look really closely, you'll be able to see red lasers being shot between the cars here. You'll see them flash. If you look very closely, you'll see red lasers flashing. That's sensing the car in the lanes, whether it's forward, left, or right, and then it keeps track of what time they approach the intersection and stores that. And if you approach the intersection before they did, then you have the right of way. Okay? And that's basically how it works. And then it's obviously able to know where the cars are. So if there's a car on your right, then they have the right of way if you approached it at the exact same time. Okay, so how does it turn? How does it go straight through? How does it turn right? Basically, it's just a preset maneuver. I've basically done the calculations at what angle it needs to turn and for how long, and I've pre-calculated in basically that maneuver. Is this probably logical in real life? No, because intersections are all different sizes, but I really don't really have the time to program calculating the exact trajectory that the car would drive, so I basically just pre-programmed in maneuvers. Okay, so let's talk about approaching an intersection and how that works, how it knows to stop at an intersection and not just drive straight through it. It's very simple, actually. You can see these orange lasers right here, these orange yellowish lines. Basically, it's another raycast, and it's raycasting and sensing that there's a intersection here. I've basically given it a intersection collider. And if there is an intersection there, once it gets a certain distance to it, once it gets close enough to it, it applies braking, and then once it gets really close to it, it slows down right to a stop. Okay? So you can see that right here. It's slowing down right to a stop, waiting for its right of way to turn, and then it will proceed, and the next car will stop at the intersection. And that just repeats. It's really straightforward. At least it looks straightforward. The program, maybe not. Okay, so I am currently working on larger intersections where there are lights involved and multiple lanes. Surprisingly, it actually gets very complicated. But I'll just kind of show what I have so far here. So as you can see right here, there's a bunch of cars or Teslas lined up here in multiple different lanes, and I've all given them pre-programmed commands of what they're going to do at this intersection that they're approaching here, okay? So if I click play here, you will see that some of them will change into different lanes because in order to, say, turn left, right, and go over here, you need to be in the furthest left lane. So if, say, this car wanted to turn left, it's going to need to lane change into this lane, and then once again lane change into this lane before it can turn left. So I do have that implemented, and it works okay. Okay? So let's just watch it here. So you'll immediately see this car right here, look, it's lane changing, and this car right here is immediately lane changing. So this car must want to go right, and this one must want to go left. As you can see here, yes, these two want to go left, this one wants to go straight, and that one wants to go right, and that one also wants to go right. So right there, you can see the blue lines here show the paths of them. Oh, that car there started going crazy. Let's not look at that. But right here, you can see the paths of them, and you can see the lane changes made here, and lane changes were made here into the turning left lane. And that's basically just, it's constantly, if it knows it needs to turn left at the next intersection, it's constantly checking to see if it's able to turn into the furthest left lane, or if it wants to turn right at the next intersection, it's constantly checking to see if it can turn into the furthest right lane, just like a human would do. They would try and get in the furthest most right lane if they know they're going to need to turn right soon at the next intersection, right? That's basically doing the same thing. And then again, once it approaches the intersection, it does a left turn maneuver, a straightforward maneuver, or a turn right maneuver. Now, I do not have implemented in checking to check what color the light is yet, and I do not have implemented in right of way. So if I were to have other cars coming from the other directions right now, it wouldn't be pretty. So that is basically what I have so far for my autonomous driving simulation made in Unity3D, and all the models I've been making in Blender. It's going pretty good. I've learned a lot. I've basically just been kind of figuring things out on my own, doing some research on how other people in real life have been working on autonomous vehicles, and then kind of being able to implement that in a simulation, because you got to keep in mind that making autonomous vehicle in real life, the roads are already there, the intersections are already there, whereas I have to also implement the roads and all the logic like that. And I've enjoyed it. I think it's going pretty good. There's definitely still a lot of bugs. It is definitely not 100%. It's maybe about 90%. I've got the 2-lane roads working pretty good, but as soon as you get over to highway 4-lane roads, it's a little bit buggy because I'm still working on it. Those big intersections are going to be a lot of logic involved with them. I kind of think I know how I'm going to approach it though. So that's my progress so far. So hopefully watching this video kind of inspired you if you were thinking of doing something similar, or just wanted to learn more about the logic behind making an autonomous vehicle AI, and really how tricky it is. It's actually really hard, and I have respect for people in real life working on real autonomous vehicle software. Thanks for watching.